Okay, so today we're going to look at special parallelograms. So we look at parallelograms, and what specifically we looked at were different properties of parallelograms, right? We looked at the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, so they create congruent halves, and then the conservative angles, those angles that share the same side are supplementary, so they equal to 180 degrees, right? These are all things that we looked at in regards to parallelograms. What we're going to look at today is special parallelograms. So more specifically, we're going to look at a rectangle, a square, and a rhombus. And the reason we're doing that is because we need to be able to identify when a parallelogram is a rectangle. So a rectangle, the way that we differentiate it between parallelograms is a rectangle has 4 right angles, right? So whenever we have a rectangle, I'll draw right here. Whenever we have a rectangle, what we assume is that that rectangle contains 4 right angles. Which are located at each of the sides, right? And so that's how we differentiate a rectangle. So we have different rectangle theorems that we're going to look at. We have the rectangle angle theorem, which again just states that a parallelogram is a rectangle if one of its angles is the right angle. So if even one of its angles is the right angle, if even one of its angles is equal to 90 degrees, that parallelogram will be a rectangle. Another theorem we have is the rectangle diagonal theorem, which basically says a parallelogram is a rectangle if and only if its diagonals are congruent. So if its diagonals are congruent, such as, let's say that B to D is 10. Well, if B to D is 10, then A to C must also be 10. So those diagonals must be congruent to each other. And what we're looking at as far as these diagonals are these right here. So B to D, 10, A to C, 10, right? So those diagonals will be congruent. So these are different ways in which we can differentiate a rectangle to being a parallelogram. So basically what we're doing is we're going to do parallelograms. So we know it's a parallelogram, but we're going to look at what type of parallelogram. And so if it classifies this criteria, then that parallelogram is going to be a rectangle. Okay? Like I said, we also have other types of parallelograms or special parallelograms, and that's going to be rhombus and square. So let's look at rhombus. So the reason that a parallelogram is can be a rhombus is a rhombus has 4 congruent sides. So each of the different sides would be congruent to each other, and that's what we classify as a rhombus. So we also have the rhombus angle bisector, which is the theorem that we're going to use. We're actually going to look at 2 theorems that we can use to prove if a parallelogram is a rhombus. So what we want to do is we know something is a parallelogram, but what we're trying to determine is that parallelogram a rhombus now? Okay, and so the rhombus angle bisector theorem basically states a parallelogram is a rhombus if and only if each of its diagonals bisect 2 of its angles. So if it bisects those angles, remember that bisect means cuts it into 2 congruent halves. So basically what it's saying is that the diagonals that exist inside of the rhombus have to cut at least 2 of its angles into 2 congruent halves. So for example, if E originally was 30 degrees, well, when it is bisected by the diagonal, it would create 15 and 15, because those 2 halves would be congruent, okay? So that's basically a classification for being able to differentiate a parallelogram as a rhombus. Next one we're going to look at is the rhombus diagonal theorem, which basically says a rhombus is a rhombus if and only if its diagonals are perpendicular. So basically, if the inside diagonals meet each other and intersect each other at a 90-degree angle, it has to be a 90-degree angle, right? Because in order for it to be perpendicular, it has to intersect at exactly a 90-degree angle. So intersect at a 90-degree angle. If those diagonals do in fact intersect at 90-degree angles, then that is in fact a rhombus. Okay. Another unique thing about this theorem, which we'll get into on Friday, is that by the side theorem, all four triangles formed by the diagonals are congruent. So as you can see, whenever the diagonals meet, they create different triangles. And basically what this is saying is that those four triangles would be congruent. So for example, if I knew that this side was 8, and this side was 9, and this side was 9 as well, well, then this would also be 8, this would also be 9, this would also be 8, this would also be 9, and this would also be 8, and that would also be 9. So all those different sides would be congruent because those four angles are congruent. Four triangles are congruent. Okay, but we'll look more into that later. But basically, to differentiate a parallelogram as a rhombus, those two diagonals need to meet perpendicularly. Okay. So classifications for a rhombus or a rhombi. Rhombus are parallelograms. Not every parallelogram is a rhombus, but rhombuses are parallelograms. They have four congruent sides, right? That's how we differentiate between them. So all their sides are congruent to each other. They have diagonals that are angle bisectors. So we can see here that these diagonals bisect those angles, so they cut them into two congruent halves. And those diagonals are also perpendicular, so they meet each other at 90-degree angles. So that's how we would classify a parallelogram as a rhombus. Okay. Again, we are looking at parallelograms. We've been able to find the characteristics of parallelograms, and now what we're going to do is figure out, is this parallelogram a rectangle? Is it a rhombus? Or is it a square? Okay, that's basically what we're doing in this lesson. So we also have squares. How do we know a square? Well, a square is actually both a rectangle and a rhombus. So it's going to classify both of the different properties of rectangle and rhombus. So a square, again, is a parallelogram. It is a type of special parallelogram. It has four right angles, which we also looked at as far as rectangles go, right? That was a property of rectangles. It has congruent diagonals, which was a property of rectangles. It has four congruent sides, which was a property of our rhombus. It will have diagonals that are angle bisectors. Again, it's a property of our rhombus. And it will have perpendicular diagonals, which is a property of our rhombus. So basically what we're identifying here is that our square contains all the properties of a rectangle and all the properties of a rhombus. And so therefore it's also a type of special parallelogram. And so to show you, has four right angles. Well, all these angles are 90 degrees, right? Has congruent diagonals. Well, what does that mean? Well, that basically means if I know that AC is equal to 10, then BD must also be equal to 10, right? So those must be congruent to each other. Those diagonals must be congruent to each other. They have four congruent sides, which we see right here. All the sides are congruent, meaning if this is 8, then this is 8, then this is 8, this is 8. The diagonals are angle bisectors. So as you can see, those diagonals cut that 90-degree angle into four congruent halves. So 45, 45. Same thing goes for all those other ones. So those diagonals bisect those angles into congruent halves. And then again, those diagonals are perpendicular to each other. So they intersect at a 90-degree angle. Okay? So now we're going to go ahead and apply properties of a square to solve an example problem. So here's an example problem, and basically what we're going to answer in this, we'll look at it right now. A new walking path around a playground is in the shape of a square. What is the approximate distance from one corner of the path to the corner opposite it, round to the nearest meter. So what we want to identify is basically what is the distance from one corner, say I choose corner B, to the corner opposite it, so D. So we're looking for what is the entire distance of from one corner to another corner, or what is the entire distance of the diagonal, right? Because that is a diagonal in the square. And so what we want to do here is identify what information we have been given. And what information we have been given is information about our outside sides. One other thing that we should know is that all of our all of our triangles created are congruent, right? Because that was a property of a rhombus. The rhombus stated that all 4 triangles are congruent. That was a property of our rhombus. And like we saw, a square is a rhombus. And I'll show you where that came from. Right here, it says, all 4 properties formed by the diagonals are congruent. That was a property of our rhombus. And a square is a rhombus, right? Okay. So that means that all 4 of our triangles are also congruent. Well, how do we find the length of the inside side? Well, what we can identify is that all of these triangles that were created are right triangles, right? All of these are right triangles. I did not mean to do that. I meant to do this. So this would be a right triangle. This one would be a right triangle. They're all right triangles. So 1 would be right, 2 would be right triangle, 3, 4. Why is that? Because they contain that right triangle on the inside. And so because we know it's a right triangle, what we can go ahead and do is use our Pythagorean theorem to solve for that missing side, right? So 80 is opposite our right angle, so that's our hypotenuse, which means it's our C. And what we're looking for is what A is and what B is. So what is the value of X? Well, combining these, we get 2X. We have 2X squares. Okay. Ooh, let me solve for that one first. 1 second. So 2X squared equals, divided by 2 now, divided by 2. X squared equals 320. How do we get rid of our square? Square root it. X equals 56.57. So that's basically telling us that the distance from here to here is 56.57. Okay? Also here from here to here. That's the information we just got. But what we're looking for is the distance from B to D. Well, because all of these are congruent, then this would also be equal to 56.57. So we would do 56.57 plus 56.57 equals 113. So that is the distance from one corner to the other corner. Okay, so this is just an example of how we could use the different relationships to solve a problem. But we'll get into some practice problems tomorrow. Okay, so what did we look at today? Well, what we started with is we know all the information there is to know about parallelograms, right? Well, now what we're going to do is we're going to use all that information and classify special parallelograms. So we're going to determine, is our parallelogram a rectangle, is it a rhombi, or is it a square? Okay? And the way we're going to do that is we're going to use the different characteristics and see whenever we're given a figure if our figure follows those characteristics. So if it is a rectangle, then we'll have all 4 right angles and then we'll have congruent diagonals. If it is a rhombi, it will have all congruent sides. Its diagonals will bisect the other angles and its diagonals will be perpendicular. Okay? And then if it's a square, it's going to go ahead and satisfy every single one of these criteria. Why is that? Well, because a square is both a rectangle and a rhombus or a rhombi. Okay? And so we'll see how this applies whenever we answer practice problems tomorrow. But the gist of what you should take away today is just be able to understand the different characteristics of rectangles, rhombi, and squares. Okay? And then we'll see what we can do with that and what kind of questions we can answer tomorrow. All right? Does anyone have any questions about anything we looked over today? And I will post this PowerPoint for you to reference as well. Any questions? If there's no other questions, you guys may log off, and I'll see you tomorrow for some practice problems. Bye, guys. Okay. Okay, Kylie, thank you.